Hello and welcome to Cloud Insiders, the podcast that brings cloud down to earth. Hello and welcome to another episode of Cloud Insiders. Today we're talking serverless and we're joined by two guests, Chan and Julian. Thank you both for joining.
Hi everyone.
Could you introduce yourselves and let us know what you do, where you're from? And Chan, if we could start with you, please.
Yeah, my name is Chan. I manage the pre-sales team at Inside UK. We are a solutions provider, partner of all the major cloud platforms as well as data center vendors. Work quite heavily with helping customers meet their requirements through technology solutions, so cloud and hybrid cloud alike. My background, in the past, I've been a freelancer focusing on pretty much most of the technology segments that we all sort of work with, the typical Windows or the Intel stack on top of VMware / Hyper-V on the data center, as well as public cloud platforms like AWS and Azure.
Perfect, thank you. And Julian?
Hi there, yes. My name is Julian Wood. I work basically for myself as a consultant solutions architect. I generally consult to large enterprises, and most recently that's been in the financial space. For my sins, I speak at various user groups on a number of IT topics, and I also run a blog, which is wooditwork.com. And yeah, history-wise, I've sort of come up through the infrastructure space. So that's been from server storage networking through the VMware revolution and all the other stuff that we built on top of it, including cloud and, I suppose nowadays serverless.
Perfect, thank you both for joining. So to start things off then, what is serverless?
Well, to begin with, it's not actually serverless. No pun intended, by the way.
What do you mean? There's servers in serverless?
The term itself is a bit misleading, isn't it, really, if you think about it. Serverless doesn't necessarily mean there's no servers. Servers are there, but it's somebody else's servers. For me, it's more of a framework or an architecture for applications that take microservices or the container approach a step further by breaking it down to even smaller portions that we call as functions. So you break it down into functions and then use a third-party hosting platform or an execution platform to house those functions. Effectively the smallest unit of compute, if you look at it that way.
That's a great intro to it. I mean, the only things I would add is on a sort of more technical level, the servers are pretty much code that's written by a developer, and the developer pushes up the code to, as Chan says, the hosting provider, and it just runs. The developer has to have no concept of any of the infrastructure that underpins what their code is doing or where it's running or how it scales up or how it scales down. And that's sort of three of the super interesting things about serverless is these functions do spin up and down on demand, and they are event-driven. So the functions themselves don't really do much, but they will watch for a database record being updated or a file being updated or an HTTP request or something like that. And that event, which can be on an event bus or something like that, the serverless management system will see this event and the function will then invoke and run its code and then shut down. That can obviously be very quickly. Part of the things on the public cloud systems that we use for serverless at the moment is you pay per invocation. So it's also a micro-payment system that per each time the function runs, you pay a little bit of money in fractions of cents.
Is this the next wave of cloud computing then, or is it something separate?
I definitely think so. I think we spend a lot of time with cloud computing talking about all the infrastructure and VMs and even containers and storage and networking and all this kind of thing. Ultimately, the focus is always on the application code and what the business needs to get and create for its business. And if we can find a clever way to abstract all of that complicated infrastructure stuff and give developers the tooling and the environment where they can just run the code that is important for their business, that is excellent. And cloud and containers and all these kind of things have created this opportunity for something, a silly name it may be, but something like serverless to be created. There's sort of two definitions of serverless. One being the FaaS, which is functions as a service, which I think sort of bears out as what we're really all talking about. But there is another definition, which is sort of BaaS, which is back-end as a service. And that's in a way where you have a smartphone to a cloud environment, and the mobile phone has an installed app, which is in effect the client and the client server part of it. And that mobile back-end, that mobile app then writes information directly to a database that's sitting somewhere in the cloud, and there is no application server in the middle. And that has been happening a little bit longer than the functions of the service, but because both are lumped into the serverless kind of thing, the mobile backend of the service is the new sort of client cloud model, although they're not application services, but you've got an application reading and writing things directly from a database, which is maybe Google Firebase or something like that. And there is an application service. Yes, it is also referred at times as serverless, but I think functions as a service is really what people are alluding to when they talk about serverless if you can say it's pure definition for a funny name.
Absolutely. I mean, it kind of liberates the developers even further from the ops guys, doesn't it, really? Because even with sort of modern, sort of common DevOps solutions that often look at containers as the sort of answer for a lot of DevOps requirements, there's an element of infrastructure that is still required, or the ops that is still required, when it comes to the container orchestration, management, et cetera, and even monitoring, providing persistency through volume plugins for storage, et cetera. With serverless, you can take that step further and reduce that ops involvement so that those ops can be used elsewhere. So some even refers to serverless as no ops. I don't personally agree. It's more of a less ops kind of a solution, but it liberates developers further to get on with their job, which is to just code and get those executed.
Of course, yeah.
Yeah, and currently, the way serverless happens is pretty much in a public cloud infrastructure. So AWS has Lambda and Microsoft has Azure Functions. And that's the current way that serverless is pretty much done. But things are changing, and serverless is going to become something that you may want to be running in your own data centers if you do keep a private cloud. And so things like IBM Bluemix and even further future things, I would think, with Azure and with AWS Lambda being in an on-premises environment may be a future direction, which could sort of change that whole operational model, that there will be a huge bunch of operations on-premises that your ops people will be doing, but your developing is being able to leverage that just writing that serverless code. So yeah, currently there is very little operations because Amazon and Microsoft take care of it all for you. But in the future, if there's going to be a push for serverless on-prem, a lot of that infrastructure is going to be still managed and underpinned and looked after by operations people.
Yeah, that's actually a good point. So, I mean, evidence of that is already there today, right? Azure Stack, for example, that lets you do the same Azure functions capabilities went GA yesterday at Ignite. So it's now shipping. During VMworld, they announced the PKF, the Pivotal Kubernetes from Google and VMware joint venture that also comes in a version that can run it on-premise as a container framework or a function as a service framework, which is another naming for serverless, by the way. So yeah, that's already happening now. I think the point I was trying to make earlier, though, was that as far as the developer is concerned, their reliance on the ops would be less than, let's say, containers, because while the ops guys manage the platform for daily, day-to-day tasks, there'll be less requirement for the ops guys to get involved outside of managing the platform. But yeah, you're right, Julian. I think it's not just for public cloud; it's there for private cloud too.
That's interesting. So, Julian, if we come to you first, so I don't know if you've come across this before, but how are organisations benefiting from undertaking a serverless approach to their computing?
Well, I mean, first of all, it is extremely new, so it's not something that is even taking the world by storm yet, but I honestly believe it is something that will do. And in 10 years' time, we're going to be looking back and it will be one of the sort of default models of computing. But just going back to the question, how are organizations benefiting? It's all about being able to iterate faster. And if you don't have to look after all the infrastructure that's running underneath your code, what can you concentrate on? Well, you can concentrate on writing code that is important to your business. And a lot of the stuff that developers have to write is a lot of things that really isn't involved with what the business actually needs. So if you can get rid of a whole lot of that heavy lifting, and a lot of the security concerns are taken for you. The scaling up and down is taken away from you, that you don't have to look after it. A lot of the availability, maybe some of the geographical locations. If you can concentrate your developers on being able to write that value-adding, super important code to your business, that's really going to be an operational benefit to an organization and potentially cheaper cost too.
Cool. Chan, do you see any other ways of organizations benefiting from serverless?
No, I think Julian summed up most of the key sort of approaches. It is quite new, isn't it? One of the main reasons people have adopted it, for the right reasons rather than because it's a cool new tech, is mainly down to the ease of scale that it provides and the ability to pay per execution, which is a very sort of cheaper cost model, like Julian alluded to. So just to give you an example, when Lambda, which is the sort of gold standard that all the serverless platforms are measured by, when that was announced, the cost was around about $19 for about 3 million executions a month. That is cheap. That saves you from having to run your own VMs with an application stack, sitting there waiting to process incoming information, or even to use a public cloud platform, or even a PaaS solution that sits there, stay ready for you to start providing data or, do something for it to, receive that information and process that. That's a high cost to pay. With this cost model, it becomes completely different ballgame for customers in terms of their total cost of ownership. So that makes a massive influence in that decision. The rest of the advantages include, like Julian alluded to, this ease of scale, the ability to deploy rapidly, et cetera, and then being able to scale almost infinitely because of the way they're architectured and the small execution times and the lower sort of resource footprint. That's why people like Netflix was quite big on adopting serverless from the get-go.
One of the interesting things about the scaling is super right about the scaling up, that these are pretty infinitely scalable. I've even been heard about people wanting to test their functions, and as a courtesy phoning Amazon up just to say, well, do you know what, we want to test 1 million invocations of our function. Amazon going, yeah, well, no problem, off you go. Thanks for letting us know, but yeah, that's not really going to cause us any kind of issues. And so that's the scaling up. But also importantly is the scaling down, that in fact, if a function does not run, your running cost is absolutely zero. As each function runs, you pay this microcent. So you can land up having a whole bunch of functions all over your organization doing all manner of number of things. And your steady state of if those functions aren't running is zero cost. And if you think of small or large organizations, they've got a lot of batch processes, they've got a lot of things that are just waiting to happen, and they need servers to run on, or containers to run on, or VMs, or even bare metal, that these things are just hanging around, watching things and waiting for things. And there's a cost associated to this. In a true serverless environment, when your function code may be all there ready to run, but when it isn't running, there's absolutely no cost. And as Chan alludes, you're getting some pretty good economics for free Lambda or free cloud functions. Just so you know, for the pricing of these, what we generally, for a function, you configure a memory limit. So that may be a meg, 512K, 128K, or even a bit more. I think it's up to 16 meg or something that you allocate per your function. And then there's a duration rounded up to say 100 milliseconds. So as a request fires, you've got your pre-configured memory plus the duration that it runs for, and then there's a sort of a concept called gigabit seconds, which is the amount of throughput that it sort of uses. It's not a great explanation, but it just gives you a brief idea. And then AWS and Azure give you one, depending on the platform, 1 or 2 million requests free a month. I mean, that's millions of requests. And if you're doing some of your operational stuff with these, your first 1 or 2 million are free. Sounds like
Absolutely.
a gateway drug.
And that's not just a marketing tag either, which is very strange in this industry, right? These numbers are quite true. I know a number of organizations that actually run production serverless infrastructure or platforms on a public cloud platform, and they are not paying a penny because they're well within that generous buffer.
Because your productivity is so much higher, you're literally running pure function code, that you're not sort of worried with, in the technical gubbins of it, HTTP sessions and authentication and load balancers and, all that kind of thing. So that, that operational impact is dramatic for current AWS and for Azure. But I mean, obviously, as this is new, there are also some of them are disadvantages, and some of them are sort of design choices. So, I mean, on some of the design choices kind of thing, they are entirely ephemeral. There is no local state in a function. So data still needs state. So things need to be written to an external disk or an external database. So it's not as though you're going to be throwing out all of your IT to run it in functions, because functions are little worker bees that are going to do something and grab something from point A and put it into point B. Well, point A and point B still need to exist as places of state. Now, they can be S3 buckets or blob storage or that kind of thing. But let's not think we're just going to be chucking everything out and everything's going to be serverless. They've got particular things that they're going to be good at. I mean, other disadvantages at the moment, I mean, performance is inconsistency. When you run a function, some of them it may have to warm up. But the way a function runs, if there's a container underneath it, you've got no visibility of the container. But if the cloud platform provider hasn't got one of those containers ready, it's got to spin one up. And if your code is Java, for example, that container needs to spin up. It needs to warm up the Java virtual machine before your container, your actual serverless code can run in that. That may take some time. So that's a thing you need to work around with the inconsistent performance. There may be noisy neighbor issues. They always shared resources, be it disk and time limits and memory and all those kind of things. So this is all new. There are pros and cons to it, but the benefits of zero operations and great scaling are going to create great design opportunities for looking at these things. But as with all things in IT, they're good and bad parts of it, and you need to decide which is good. There's no one size fits all.
So, Chan, in that last conversation, you mentioned microservices. So, what's the difference between microservices and serverless, or do microservices play a role within the serverless stack?
For me, they're kind of the two sides of the same coin. That's my personal view, because they're effectively very much intertwined. Like Julian mentioned, the container functions require containers behind the scene depending on the implementation in different platforms. Mm-hmm. But you can also have a container instance being kicked off as a part of a serverless function if you need to, which is how most of the implementations work in reality. They're very much used in harmony, but there are fundamental differences that make serverless better for certain cases.
Perfect.
Yeah, I think the distinction will be sort of how much you roll your own containers. I believe there is, I'm just trying to remember offhand, but there is one of the serverless ecosystems does actually allow to bring your own container, which is an interesting, so you can create your Docker container with whatever you want in it and send it to one of the providers, which will then run that container for you. But normally that isn't the case. Normally you've got a limited set of coding languages that can use things like normally is JavaScript or maybe C# or PHP or Batch. Node.js is popular as well.
Node.js, yeah.
Yeah, so I think Node.js is pretty ubiquitous across all of them. But I mean, someone like Azure, as you can imagine, would have PowerShell, and in fact, it's Apache OpenWhisk that you can bring your own container. But that's not the normal way. Normally, you just provide your Node.js code, you zip it up, upload it to your platform of choice, and that's going to run. In the back end, yes, it's going to spin up a container which is going to have the Node.js runtime in it, or for another language, Python, Java, .NET Core runtimes in it to run your code in it. That's something you have absolutely no visibility of. If you're going to be running it in the future on premises, and even there are examples now with something like Apache OpenWhisk, which is from IBM, or something like Platform 9's Fission, these are on-prem container orchestrators that can, and frameworks that can then run serverless on top. Then yes, then you'll be managing a whole fleet of containers by yourselves. Generally, they seem to be managed by Kubernetes as an orchestrator. So Fission and OpenWhisk use Kubernetes to spin up all these different kinds of containers. And yeah, then you're going to have a whole lot of work managing a fleet of containers. But in the public cloud system, that's all somebody else's problem.
So Julian, obviously I know you mentioned it was new as well. Serverless was very new. What trends are you seeing driving the adoption of serverless computing?
I think it's things we were talking about previously with the adoption for organizations. It's just not being able to have to look after the infrastructure, being able to reuse code more efficiently. And so being able to share code and is going to have a lot of interesting opportunities. That instead of purchasing a whole application to do something, you're going to be able to rent somebody else's serverless function to do something, be it a transformation on a financial price or reading from an IoT device, or looking at maybe a passport, say a passport scan that's been sent up to some cloud system, and you're a financial provider or want to do a loan. You read that passport and you want to pull out the passport number. A serverless function can do that. But you're going to be able to rent these serverless functions from other kinds of people. So this whole distributed nature of applications and services is, I think, going to have a massive explosion. And then also, I think, hugely importantly, is this functional billing. So you can break down your apps into its functional parts, and some of those parts you're going to run yourself, and some of those you're going to rent from somebody else. But the amazing thing from that is you're going to be able to see exactly what function each function costs to run. And that's going to give you great advantages, because currently, whether you've got a monolithic application, or even if you have done some microservices things in a container, that's not at a functional level. And you really have no idea what parts of your monolithic or even microservices application costs to run. And if you can find out per function what it costs to run your application, you can direct your developer time to either reducing expensive functions or adding value to the functions that you know make a lot of money for your business. And you have a very clear way to be able to direct the investment in for your developers.
That's interesting. So serverless has been around for almost a decade now. Why is it just becoming mainstream?
Well, from my point of view, I wouldn't say a decade. I would say that really properly serverless is only introduced by AWS Lambda, and that's November 2014. So it's sort of nearly 3 years ago.
Yeah, I think I'd probably share the same view. So it comes down to one's interpretation, isn't it? I mean, it's like, serverless could be a bit like cloud in a way. Cloud means different things to different people depending on who you speak to. Some may argue that serverless, SaaS could be serverless because, they don't have to worry about the backend server infrastructure. You just use the software application as a service. Some may argue passive serverless too. So it depends on one's interpretation of what serverless is. It kind of took off, picked up a lot of pace when AWS enabled API gateways back in 2015. So that's when it really sort of kicked off. And since then, obviously, everybody else has sort of jumped on the same bandwagon. So Azure Functions been available for some time now. And then, they've got things like Logic Apps as well. That makes it a lot easier for people to sort of consume. And then Google coming in to play with, their own version as well. So all of these vendors jumping on board is part of the reason why it's becoming mainstream now, because it's got enough coverage from all the major players.
Okay, that's interesting that you both said Lambda. Yeah, when I was doing my sort of research into the questions, that kind of stuff, I know there was a few. I didn't write the companies, and it was it was Zimke, I think it is. So that was the first instance of pay-as-you-go code back in 2006, and then 2008 was Google App Engine. But I'm guessing, I agree with you guys. It's kind of Lambda is where it started, really.
That's interesting, because Zimke was actually set as the first PaaS.
Okay.
And it did have functional billing and was a PaaS. And then this comes onto another whole definition of what the difference between PaaS and FaaS. But yeah, Zimke was the very first PaaS that was done. I will let the jury decide whether that PaaS was in fact a FaaS.
You have to put a poll out at the end of the recording to see what the votes are. So excellent. So I know you both mentioned Azure and AWS. Are there any other key players? If there are, what are they offering?
From my perspective, I think Google is going to be a force to be reckoned with the, especially with the partnership between VMware and Pivotal as well. They're going to be able to tap into that well-established, very mature enterprise data center market to start stealing some of those workloads onto their function as a service platform. But yeah, from my perspective, Lambda and Azure will always lead simply because they got there first.
Yep.
That's how things work in this industry, right? and while everybody else catch on, those guys will keep adding capabilities onto their platforms that will keep them fairly significantly distance away from the other competition, especially now that both Lambda, AWS platform and the Azure platform are building in next-gen technologies like, artificial intelligence, machine learning, et cetera, that will be available for a function function hosted on a Lambda platform or Azure Functions framework to use. The capabilities of or the possibilities of using serverless infrastructure is going to be pretty immense. E-commerce would probably struggle to catch up.
And AWS and Azure have a distinct advantage that because serverless relies a lot on this event bus where it needs to read and write information. Well, AWS and Azure have these amazing set of integrated services already there. So AWS, if you just think of S3 or CloudFront or DynamoDB or Code Pipeline or SNS, all these different kind of things, those are already tied into Lambda to be able to fire off functions when there is an update to any of that. Azure has similar things from its storage and media services and some of its machine learning stuff, and even its content delivery network can allow you to do different kind of things. So because these public cloud environments have such big ecosystems that they've built for their own event triggers, that obviously gives them a distinct advantage. But if you're wanting to go it yourself, there's sort of two different ones. As we've mentioned before, it is container-based. So Kubernetes-based ones. There's a Fission from Platform 9. There's Kubeless and Function. So they are roll your own serverless offerings that you could run on a public cloud if you want, or on your own data center. And then there are also some more cross-container platform ones. Apache OpenWhisk, which you mentioned before, and then other ones called Iron Functions and Funkatron. So if you're wanting to do your own serverless, there are some other options out there other than the big three cloud players being Amazon, Azure, and Google.
Cool, thank you. I know we've already touched on the organizational benefits, but what type of businesses are you seeing adopting a serverless approach? And Chan, if we can start with you.
Yeah, I think if you look at the actual architecture and the benefits associated with it, most people would naturally make the conclusion that most born in the cloud sort of startup type of organizations are the main adopters of serverless. But in my experience, based on what I've seen, it's actually quite the opposite. The largest consumers of serverless are well-established large enterprises that are typically associated with having this monolithic, client-server database type of applications. They're the ones who are consuming this more often based on my sort of experience, because they start using serverless approach to start breaking down some of those complicated monolithic functions into a more distributed, easily scalable environment as a part of an existing application setup, distributed application. So for me, yeah, absolutely. Those large enterprises. To give you a couple of names, I think people like Thomas Cook in the UK, I know they're one of the flagship use cases. So it's a large organization that uses Lambda to power some of the search capabilities in the back end. I think at one of the AWS events last year, Nando's came up on stage and mentioned how they use Lambda, at a global scale to power their Nando's app that we all use, on our phones, some of us on a day-to-day basis. So, yeah, mostly large customers, I'd say.
Julian, do you see the same?
I think
large enterprises?
Well, I think the use cases are so broad that there are inevitably going to be different pockets that do it. I think startups, due to the lack of friction to get going, it's an obvious one. But also for exactly the same reason, the lack of friction to get going is what attracts big enterprises to do it. And we're not saying they're going to be changing everything, but enterprises, even if they've gone cloud native, spinning up a VM or spinning up a container is still not the simplest thing in the world, with a lot of the organizational processes that need to go around that. So obviously, if they've got access to serverless functions, that's the quickest way to get something done. And in a way, it's just another iteration of, or can be another iteration of shadow IT, where you don't need to go through your internal processes to write some code. I'm also seeing two different reasons for doing serverless. One is from an external-facing approach. So yes, if you have an external-facing website and you want to have things more in microservices by functions, yeah, that's fine. And that's actually rewriting the business applications. But also what I'm seeing is a lot of is enterprises starting to refactor some of their internal processes. So a lot of them are small little bits of code they currently have to move something from here to there, or to move a file out to all around the world, or to do a lot of compliance reporting. I'm seeing very interesting use cases with that, where compliance reporting can be very onerous, and there's a lot of different bits of places you need to monitor and grab information from. People are starting to write serverless functions to be able to do some of that compliance reporting, and also some of the testing or even security that if you know, for example, that a file that's matching X, Y, and Z is being put into an S3 public bucket, well, you can fire off a Lambda function that can check that file for, has it got any customer information, or has it got anything like that. So there's some security concerns that Lambda is helping with. But yeah, as I say, the low barrier to entry means there are many, many use cases. Some of them are external, and a lot of them are also internal for optimizing the internal enterprise processes.
Excellent, thank you. Chan, what are Insight doing in regards to serverless?
So serverless is an ingrained part of our cloud strategy. We're the largest Microsoft partner from a licensing point of view, and also a large cloud solutions provider partner globally. And we are quite close to Microsoft and the Azure journey. So we're working quite a lot with them, trying to help customers understand, what workloads are suited for cloud. And when you do take it to cloud, or when you plan to take it to cloud, how best to take it there. So we do a lot of work with them. And as a part of that journey, serverless plays a big part, especially when it comes to having to re-architect applications. So it's that consultative approach of where we're looking at customers' environments, and a solutions architect, providing that intelligence to look at the applications and say, right, move these as is as tactical gains, these applications, break it down into these functions, and then either use microservices as a shipping engine to move it to cloud, or use the serverless to truly benefit from, massively reduced TCOs. That's our approach. And same applies when we work with AWS as well. Again, we are a large AWS partner globally, so we work quite a lot with helping customers embark their sort of cloud journey onto AWS for sort of existing on-premises based customers. So same approach again, as a part of the cloud migration. Part of an application re-architecting is almost a must in most cases, and where possible, we would position microservices and serverless approaches based on the existing application stack. For net new customers who are almost kind of born in the cloud type of customers, it's pretty straightforward. Our approach is very much consultative still. We don't quite yet believe there's enough market for us to provide a sort of a pre-scoped, scalable type of engagement, because subject is too complicated to be covered within it's not like giving somebody a bunch of SKUs for different type of servers, right? It's a lot more complicated. There's a lot of things you need to consider. So we don't quite believe that that's the right approach at this stage. It's very much consultative, focusing on Azure and AWS.
Perfect, thank you. And Julian, what about you from a freelance or consultancy point of view?
Well, I'm seeing people, first of all, getting excited about the possibilities, and then obviously some being brave enough to try. The push for containers and microservices has been very interesting from an infrastructure standpoint, but being able to abstract that all away and have developers just push code and have it run somewhere is very compelling. But that obviously means there's a way to literally redefine the whole development program. Enterprises are still struggling to decide, in what cloud do various things run? What are they going to put in AWS? What are they going to put in Azure? What are they going to run on-prem? This makes these architectural decisions with serverless, which currently are very much tied to the individual platforms, quite pertinent. And that's where consultants who have a broader view of the ecosystem and the different offerings can play a part. There's a lot of navigation to be doing. The tooling's very immature, and it's complicated doing testing, debugging, monitoring, and all these kind of things. So there's plenty of opportunity for companies to partner with freelancers and consultants to at least help people to kick the tires, and to help sort of take some of the DevOps stuff they're doing already and move it a bit further along.
Excellent, thank you. So this one might sort of take us into a whole nother podcast, but in relation to the Internet of Things, and their applications, how is the serverless approach beneficial?
Very relevant, isn't it, really? Because the first thing that should come to my mind when anybody mentions Internet of Things is data. Large portions of data. A lot of data being generated by so many different sensors that are going to be embedded, if not already has been embedded, in so many devices that we touch as consumers, right? Be that a phone, watch, devices, household appliances, which all monitor the environment around them and start collecting those data. If not already, serverless, it will play a massive part in the future of IoT and the collection of data, the analysis of that data, and then taking actionable intelligence from that data. So AWS IoT is extremely popular for that purpose, and so is Azure IoT Hub, the way the data is streamed through Kinesis, and then all the other components in the AWS engine, like the rules engine, applications, device shadows, registry, etc., that works hand in hand with Lambda to take different actions once that stream of data comes in. Azure works the same way. It's going to make it a lot easier for people to start just pointing their devices straight at those front ends of the serverless platforms. I can't reveal the name of the customer, but there's a customer who wants to use a custom code in their handheld scanners so that the data would be sent directly from the scanners straight through to Kinesis to be processed by the AWS IoT engine without having any app service in between. IoT is going to drive the adoption of event-driven services such as serverless to the next level, in my view.
Absolutely, I 100% agree. I think, over the past decade, there's very much been this move towards the center as things have moved together into the public cloud. Well, the IoT just opens that all up and starts to move some of the cleverness back out to the edge. And serverless is perfect for that. In two examples, well, IoT is all about small devices at the edge, and they're communicating back to the cloud for data gathering, analytics, etc. And having functions running on those edge devices can be excellent because they are very small functions running on very small devices, and they can do local analysis of the data. So it could be a temperature sensor, for example, and that could have some clever code that says when the temperature reaches above a certain amount or below a certain amount, then to trigger a function to send that data up to the cloud, because potentially you don't have the bandwidth, or you don't have the battery life, or you don't have something on that small device to be able to send everything up, or you may not want everything up into the cloud. So using serverless, small little mini serverless functions running on your small mini IoT devices can be certainly a use case to have very localized decision making. And then, of course, once all their data is up in the cloud, and there's going to be plenty of serverless that's going to be calling AI functions that read data, do the analytics, move data from here to there. From both sides, within the cloud and at the edge with the serverless, at the edge with IoT, serverless is going to be hugely beneficial.
Perfect, thank you. So to finish things up then, in terms of future trends, where is serverless computing heading? Chan, if we could start with you.
Yeah, I think once the tooling's there, once the frameworks develop and the ecosystem becomes bigger, I think it's a massive untapped opportunity that will just keep on growing. I think yesterday they announced the Cosmos DB integration with Azure Functions, for example. So those platform capabilities are coming as well. That was just one example, but those similar improvements on the platforms or the framework platforms are being made on a daily basis. As and when they come through, it will become more and more popular.
Yeah, definitely. Thank you. Julian, what trends do you see?
Well, definitely. As Chan says, that all the tooling and things certainly needs to involve. The other two things that I think are going to become important, or already are for the first one, is some of the service fabric ideas. So as we fragment all of these applications into many, many functions, that's a tough thing to corral and start to have a state that flows between them and start to have transactions that flow between them. So things like AWS step functions and Azure Logic apps allow you to group many of these functions together so they can act in a bit of a more cohesive way. And that's, I think, as that develops, that's going to make it simpler to get on on board and make them more robust. And then also the whole vendor abstraction. So some of the frameworks like the serverless framework or the Lambda framework, where if you've got code that you've written are going to be able to work across multiple cloud environments, that's going to be something very interesting to look at. And with also that extension to on-prem environments. And so as people are going to start seeing the benefits of serverless in the public cloud, how are they going to be able to leverage it and set up something in their private cloud?
Perfect. Excellent. That's a good way to finish, I think. Thank you guys for your time today, and thank you very much.
No, thank you very much.
Yeah, no problem. Thank you. Thank you, guys.
Thank you for listening to this episode. Find out more and listen to additional episodes on Cloud Insiders FM. Follow us on Twitter @Cloud Insiders and subscribe on iTunes. See you soon.